Sorry, you.
Yep. Hi everyone. This is the second chunk of the second part of our meeting. I'm sorry that I just realized that I had actually skipped Shreyas and Shane, who were scheduled before the break. So we're actually a little bit tight on time for the second half. I'm going to start screen sharing here. I have Shreyas' slides here in the room. So Shreyas share. Okay. All right, go ahead, Shreyas, and you can flag me to switch slides.
Yeah. So next, I guess. All right. So NERSC is the production HPC and data facility for DOE. So we're actually downstairs, and those of you in the room can look outside in the monitor over there, and you get a quick snapshot of what's on the floor as they're building our new supercomputer. We cover the broad range of Office of Science research. So I'll skip to the next slide, just in the interest of moving forward. So Cori is basically our new system. We have the first half of this machine, which is focused on data workloads. But the idea is once we have it built out, there will be a data partition and an HPC partition, which will have a fair bit of capacity. Shane, do you want to say something else about this? Or?
Yeah, so it's a mix of Haswell and Knights Landing, and we're really targeting the Haswell partition for data, and the Knights Landing is more for traditional HPC workloads, so scale up modeling and simulation.
Next slide. So in terms of what we want to do with Jupyter, I mean, these are some of our motivating use cases. So we found that Python has actually become the most popular language and tool across NERSC if you look at what each person is doing. So even people who are running these HPC codes are actually a lot of times wrapping them inside of Python and doing things there. So a lot of users just want to be able to use Jupyter notebooks to drive these jobs, to maybe run post-job analyses. They want to have access to NERSC resources such as the global file systems or access to the batch system to submit jobs, access to be on the NERSC network so they can talk to various other resources like databases. Other things they've been wanting to do is add their own libraries into this notebook environment. And then we actually found that users were basically starting to bring up IPython notebooks on the Cori nodes. And some of these were without authentication, and we were like, all right, this is not ideal. So we decided it was probably better for us to run the notebook service and then allow people to come in through a blessed channel. Next slide. All right, so what we have right now, and this is what I presented last year, was basically we have JupyterHub running inside of a single container. So everything basically runs in here. Users log in to this JupyterHub service. They spin up, which spins up a notebook server process, and users can do stuff in there. It has access to one of the global file systems, so you can interact a little bit with what's at NERSC, but it's a somewhat limited service. And even so, we still have over 100 users just with that limited service. Moving forward, we're in the middle of it. I think Shane and Bralin and myself, we just got this working last week. So we actually have it working so that we run a JupyterHub web service that basically sits on a standalone web server, runs inside of Docker, mostly to make it easier for us to move things around, which logs into our grid CA to get an authentication token, and then uses an SSH spawner to spin up a notebook server process on the Cori login node, which now means that you have access not only to the global file systems, but also to the Cori, the Lustre file systems, the fast scratch file systems, as well as the batch queue in there. So you can actually interact with your jobs now. All right, next slide. So in terms of authentication, we wrote a custom authenticator. And Shane, maybe you want to just quickly talk through this since you did most of the work here. So.
Yeah, I mean, there was an existing MyProxy authentication piece that Shreyas and others, I think, had written in the past. And so the only hassle was it was not Python 3. So that was the most frustrating part. But once we got that converted over, so it, again, it just talks to the proxy server gets back a certificate. And right now what it does is it just stores it in a file with the user's name as part of the file name, so that the GSI SSH plugin can pick that file up and use it to authenticate.
Yeah, and one of the other things I want to point out is that our old architecture, sort of JupyterHub had to run as root. We had to have a lot of permissions, which is why running that on a query node would be risky, because now you don't want to run something as root and then expose. Yeah. So the nice thing about this setup is that there's no root access required anywhere. You run the JupyterHub service as an unprivileged user. That can, as long as it can talk to this my proxy service and get the credentials. So it's a lot easier to deploy this without having to worry about what our systems folks are sort of knocking on our door about. All right, next slide. In terms of the SSH part, it was interesting because there wasn't really an SSH spawner for JupyterHub, so we ended up writing this. There was something kind of sort of like that Andrea Zonka did, but that was using SSH tunnels. This is really just a simple spawner that will SSH into the other node's start up a process and then just goes away, and then the process is communicating over WebSockets at that point. So you don't need any tunnels or persistent connections. So the basic SSH spawner can use SSH keys, but we also had some additional work there to do GSI certificates. And we essentially just keep track of the process ID on the remote host. And so you can basically do an SSH and do a kill -0 to pull it and then shut it down as needed. So hopefully we can put that out there soon. And then Rollin worked on this little IPython magic for Slurm, and I'm still seeing commits coming in today. So he's been adding functionality, but the idea is this is what we're using to interact with the batch queue. So you can essentially use these percent magics to craft up a job, to submit the job, to slurp up your results. And using pandas mode, you can actually nicely format the results, look at them, and parse them. And thanks, Fernando, for that suggestion from a few weeks ago. So
it worked.
Yeah.
Good.
So yeah, other features. So we had a couple of other custom mods we did here. We have this set up so that users can actually browse the entire file system while still being rooted in their home directory. And so the idea is, if you look at the little screenshot there, when the user lands by default in their home directory, but they can kind of browse through and get access to the query scratch system or the project file systems. Other file systems are visible to them, but they're also being defaulted to their home directory. We had a minor feature request that I'm going to plug over here. If there's some way to do a tilde expansion, that would make our lives a lot easier. And I actually have a small patch, but I just wasn't sure. There's like 4 different places it could go in the code. So I'll talk to you guys about where it should go.
Yeah, sure. Just open an issue and we can talk about it.
Okay. All right, and so yeah, so that's what we've got. So in the future, I think what we're going to look at, maybe for a demo for supercomputing, is being able to maybe drive a Spark job from a notebook via query that runs on the query nodes. Being able to spawn these jobs not just on the login nodes, but on the compute nodes directly. And in general, maybe just having some tighter integration with MPI jobs and HPC workflows.
Another one is Dask. We want to be able to try doing Dask.
So Spark/Dask.
But in a broader sense, where we're really trying to take this is we want Jupyter to replace the command line shell.
So let's go with the next
is
slide.
that the next one? Okay.
So these are kind of our users. This was from a year ago, so it's a small sampling of our users. We've got a bigger set now. Next slide. And yeah, that's what you were saying, right?
Yeah. This is where we want to get to. Is this is the way people would interact, and then they can capture more of what they're doing. It's not lost when they exit the shell. Maybe it's in history, but there's a lot more context, and also the ability to be able to directly have visualization appear in sort of the same context as where you're driving your commands. That's what we're wanting.
Yeah, so the vision really is the notebook becomes the shell in some ways for passive users. All right, and some of what we're doing is still a work in progress. Give us a couple weeks and we'll be able to put it package it up nicely on GitHub, but it's there right now in some form.
Yeah, it's a lot of duct tape right now.
Cool. Thanks, folks. Since we are a little bit behind on schedule, I would suggest that we hold off on the questions. I don't want to keep bumping the rest of the speakers back. So let's go on to maybe
Can you
the.
just make sure everybody knows about the Github channel? Who's on the call?
Yeah, I should. If you go to the GitHub repo, there's a link to the Github channel there where you can also post kind of sideband questions and whatnot. So how do I stop sharing here? Stop sharing up here. Okay, and so our next talk now is Mike Milligan. Michael, you have the floor. Are you with us?
I am indeed. Can you hear me?
Yes, we can. Perfect. So go ahead and screen share, and I'll mute ourselves on this side. Thank you, and sorry for the bump on the timing.
All right, you got my screen?
Yes, we do. Perfect. Go ahead.
Great. So yeah, I'm going to talk to you about how we're using JupyterHub at MSI here. And first, a quick overview of sort of the architecture that we're dealing with here. Very differently from a couple of talks we heard in the morning. Here, the limiting factor is not DevOps time. The limiting factor is fitting JupyterHub into an already pretty large and well-established infrastructure. So at MSI, we've got high-performance computing as well as various interactive systems and various portals and other front ends that sit in front of those systems. Our current headline cluster is the box called Masabi under high-performance computing there. We've got about 20,000 cores of reasonably recent Intel cluster there. And it's a heterogeneous system, so some of those nodes also have GPUs attached. Everything's tied together with a global high-performance file system, but we also have some additional storage options like a Hadoop cluster, a Ceph-based second-tier storage system. So there's a bunch of things that we have access to here. And in terms of scale, just for reference, we have in the neighborhood of 3,000 users spread across a couple hundred research groups. But our JupyterHub deployment is still pretty new. We just announced it publicly in May. So we've got about 50 or 60 people have actually used it at this point. So use cases at MSI basically break down into two categories. We've got the supercomputer gateway for interactive HPC lane, and in addition, we're looking at using it as an enabling technology for data science gateways. So as a supercomputer gateway, there's a few particular things that we want. We are using it, we're advertising it as a way to do interactive prototyping and visualization for the popular language kernels, currently Python and R, and if there's strong demand for other languages, then we're happy to install those. Just a question of, there needs to be enough demand that we can justify the ongoing effort to support them. Providing access to parallel tools. We provide access to IPyParallel right now. In the future, we're very interested in getting people using Dask here as well. And then as far as interactive HPC goes, this is seen as an alternative to SSH, especially the notebook, since you can run commands and capture your output. But also the web terminal feature in the Jupyter server. People like that a lot simply because they can also get a terminal that way without jumping out of the web browser, just staying in their browser, using it there alongside their notebook. And similarly, as you saw on the previous slide, we have remote desktops as one of our interactive services right now. And we're seeing this as an alternative to those remote desktops, particularly either using the notebook for graphical visualizations or, again, using the terminal. Because what we've found is that actually a lot of people, because SSH can be kind of painful, will actually start up a remote desktop just so that they can run 2 or 3 terminal windows side by side on our system. So secondly, we've got this idea of using it as an enabling technology for data science gateways. The idea there is that at MSI, we do have a development group here. That's actually the group that I'm in charge of. One of the jobs of that development group is to collaborate with our researcher users. We get written into grants, or they contract with us for some of our time, and we'll work with these groups to build various services out. So for some of these projects wind up being essentially data-driven projects where they're finding some way to expose a data set or work with a data set, and you need a portal technology for that. So rather than building a bespoke thing, we're looking into using Jupyter as essentially the foundation of portals. And for that, we would be leveraging Jupyter widgets and possibly the notebook dashboard tools that let you create more interactive displays from a notebook. And these, in contrast, would typically be running in containers that are segregated from our main systems, as opposed to the supercomputer gateway notebooks, which are running directly on our main systems. So the technology stack that we're looking at here, and again, this is all living within our existing infrastructure. So this is deployed by Puppet, managed by our existing service stack. We have a VM running an Apache web server, and that web server is doing reverse proxying through to JupyterHub, as well as SSL termination and talking to our SSO. And our single sign-on is actually sort of a blend. It can do shibboleth, and it defaults to using our university's shibboleth service. But we also have to allow for certain classes of users that don't have university IDs, and then they go through a different sign-on process. We have certain classes of users that, because they have sensitive data, are required to go through a two-factor authentication, so they have a different sign-on. So we have an Apache setup that abstracts all that away and just puts headers in the request that tell the underlying web app that this is the user, this is the group they're in, some other metadata like that. So using Apache lets us abstract all that away from JupyterHub. So Apache is proxying things through to the configurable proxy, which then talks to the hub. The hub server, we just have it living in a virtual machine in our infrastructure cluster. Nothing special there. In fact, we're actually still just using the SQLite database. We haven't it hasn't grown to the point where we're challenging the performance on that. And so we are using Batch Spawner. We're using Batch Spawner with its profiles feature, and I'll talk about both of those in a second. And we're using the remote user authenticator, which is a very, very simple authenticator. It's about 20 lines of code, and all it does is take usernames from the headers that Apache sets and pass those through as the username to use in the spawner. So that is a trivially simple way of doing authentication if you've got a web server set up that can already handle all that complexity for you. And then finally, in terms of running the actual notebook servers, that's happening on our supercomputing cluster's compute nodes, going through a job scheduling engine. That's what Batch Spawner is doing for us. In our case, we're using Torque as our scheduling system. So a few words about Batch Spawner. Anyone who saw the SciPy talk about this last week will note this is a different URL than was announced then. We've since moved Batch Spawner into the JupyterHub org on GitHub. Batch Spawner is a generic interface to job scheduling engines. What that means is, it currently supports Torque, Slurm, and SunGrid Engine, or Univa, as I think it's been renamed now. But supporting a new engine is, 20, 25 lines of code, depending on how complex it is to drive that engine. It's been designed for the every site is unique world of HPC. There's really no such thing as a generic HPC configuration. And the way we responded to that is to make Batch Spawner heavily customizable. So essentially all of its work is done by templates that the site admin can configure in your JupyterHub config file. And there's no particular assumptions made about the architecture or security model. The idea is the site admin will write templates for job scripts, for job submission commands, etc., that will work on their system. And in fact, the only difference between like the Slurm versus Torque spawners are differences in their default templates. And different functions for understanding the vagaries of how they return a job ID, for example. That's just parsing. So this is in use right now. As I mentioned, we did a public announcement back in May here at MSI. So it's in a public beta phase of production here. And just corresponding with people, I can say that there's somewhere between half dozen and a dozen institutions that have various levels of prototype deployments. So this batch spawner is getting used and getting tested, and I'm getting pull requests on GitHub and all that good stuff. So then included in the batch spawner repo, we have something called the profiles spawner. And the idea behind the profiles spawner is that we are allowing the user to control the spawning of processes without introducing any user data that's inherently unsanitizable. The sort of the simplest possible way to use the spawner options form was envisioned as letting a user type in some extra options that would get fed to their notebook command line or something. And the problem is there's no reasonable way to allow all the possible things that a user might want to input without potentially opening up some unanticipated vulnerability. So what we've instead done here is allowed the site administrator to specify various configurations for the spawner, and then essentially allow the user to specify which of those configurations that they would like to use. And this is generic enough that, so you remember from Min's introduction, there's this state structure that is persisted in the database, and we are capturing the full state of the spawner, including what class you're using to instantiate the spawner in that database state, which means you can use completely different spawners in different profiles. You can you could, in principle, you probably wouldn't do this, give the user the option to use a local process spawner on the web server, or a Docker spawner, or a batch spawner profile. We do not, in fact, do this here, but I have an example of doing exactly that on the in the docs on the GitHub repo for this. So just a quick ad, I gave a talk on this last week at SciPy, so the slides for that talk are available online too. So sort of feature requests, things that we are working on developing, or things that we would like to see someone else work on for developing. User-facing feature requests. People really want us to reinstate the IPyParallel Jupyter tab. This we think is now a solved problem. We just need to implement the solution. So that's going to be exciting, giving people the ability to sort of quickly spin up those clusters from the Jupyter dashboard. And then related to that, there's several Jupyter extensions that we would really like to see. Some of these we know how to develop, some of these we don't. So a JavaScript-driven VNC client, similar to the JavaScript terminal tool, would be a really cool addition. We think it would be relatively simple to implement, running it alongside the notebook server in the same way you run a shell alongside the notebook server for the terminal tool. And that would actually allow us to completely replace some of those remote desktop applications that we maintain. And again, a way that users like, because they're then not required to jump out of the web browser. Something that we are working on internally here is integration of Globus file transfer APIs. Since we've already got the file browser in the Jupyter dashboard, it'd be nice to integrate some of the services that we advertise for people to use. And here we make heavy use of Globus as the sort of recommended way of ingesting or extracting large amounts of data. And the ability to forward web dashboards that are created by miscellaneous services. For example, the Dask project produces a really cool web display of the progress of your computation. But right now, since that would be running on a compute node, it's there's no straightforward way for a user to actually view that if they've started Dask from their notebook server through JupyterHub. But again, that shouldn't be difficult to proxy through. We just need to do the plumbing to do that. And then on the developer-facing side, the big thing that we are looking at right now is trying to develop a better understanding of how to plug external modules into Jupyter's testing framework, so that we can give things like Batch Spawner the same level of continuous integration testing coverage that Jupyter itself gets. And I believe that is the extent of my slides.
Thank you, Michael. That was great. In the interest of time, since we actually are now a little bit seriously behind, I'd like to maybe hand it over to Ian and the PIMS team. And hopefully we'll have a bit of time for open discussion at the end, but at least I want to make sure that I don't end up cutting off any of our speakers. Sorry about that.
No, not at all, not at all. I'll stay on for questions later. I'll be around.
Thank you. Ian, James, and Michael, you folks have the floor.
Okay, I'm just about to try and share my screen. Show up for everybody?
Yes, we can see you.
Okay. Okay, let me jump back to the beginning. Okay, ready? Okay, so I'm Ian Allison. I work for the Pacific Institute for Mathematical Sciences. And we've been using JupyterHub along with Docker, and I'm going to talk a little bit about what we're doing with Docker, Flocker, OpenStack, Ansible, and Vagrant. It's quite a mouthful. Just to introduce who we are and what we're trying to do. So I work for an institute called the Pacific Institute for Mathematical Sciences, or PIMS. So we have site offices at most of the major and Western Canadian universities, along with UW. And we have a really broad mandate that mentions things like promoting research and applications of the mathematical sciences. As of July 1st, we have a new director who's on the call somewhere, James Colliander, who has really strong interests in learning technologies. He's actually the CEO of a company called Crowdmark, a learning technology company called Crowdmark. And our plan together is to try and make Jupyter Notebooks as widely available to all Canadian researchers as we can. That's sort of the global goal. And in doing that, we're working in a partnership with a body called Compute Canada. And Compute Canada is their national level research partner up here for high performance computing. And they provide resources and support for this sort of thing. And specifically for us in this project, we're creating an OpenStack installation that we can muck around with. And we've signed a memorandum of understanding with them very recently, and we now just have to get on and actually build something. So at the moment, we have some JupyterHub installations. They're pretty traditional and very similar to what you've seen already this morning. So we have classes in math, computer science, or data science, things like that, that are using it every day. And we also have sort of casual use by researchers. So once people find out what we're doing, they're very interested. They don't want to have to run their own Jupyter installation or their own JupyterHub installation. So we add them in with us. And we have some summer students working alongside us doing some really cool data science stuff. And we're in talks with a lot of the research people up here to see how we could integrate Jupyter and JupyterHub into their work. Typical instance for something that we're doing, something up to 16 cores, something around 64 gig of memory, and these are all just VMs. We use ZFS and NFS for storage, and then Docker Spawner, actually system user spawner, the child class there, and their authentication is PAM, by LDAP in the background. Okay, so that's what we're actually doing at the moment. What we want to do is offer the same service or similar services to an order of magnitude more users. And of course, a big part of that's going to be federated identity, since we're not talking about a single institution, we're talking about various institutions across Canada. And so we're looking at Shibboleth and to do that there to take care of that part. And we're also looking at different types of hubs. So at the moment, we are very aggressive on our C group constraints within Docker so that we give users just a little slice of the machine. But we'd like to be able to relax that for various more sort of HPC-oriented groups. We're conducting sort of an experiment with a single largish installation of JupyterHub, just to see how far we can push it and sort of learn where our breakpoint is for when do we spin up another hub, or when do we shove these groups together. And so we're just sort of trying to learn that out. And the tools that we're doing for that, similar to a lot of other people, are Docker Swarm and Flopper to take care of our storage. Sort of in parallel to that, we're also looking at doing automated deployments. So when we realize that it's time for another hub, just try and make that process as smooth as possible. Very simply, what we're doing, or the transition that we're making just now in terms of what we have and where we want to go, we're replacing Docker with Docker Swarm and NFS with Flopper. So Flopper has all of these nice distributed backends and it's supposed to just make volumes work for Docker. So it doesn't matter where your container runs, it just gets the volume. And then the volume in that case is the user's home directory. Okay, and we want to do this as completely hands-off as we possibly can, with the realization being that there's going to be a lot of hubs and we don't want to spend too much time administering all of this stuff. So we're using two main tools, Vagrant and Ansible. So Vagrant, if you've come across it before, just reproducible development environments. The key for us is it gives us an automator, like a very quick way to bring up, to define resources and then instantiate. It supports a bunch of different providers, so things like OpenStack, Rackspace, or AWS. We're on OpenStack at the moment. And then it will run, it has this concept of provisioners, so it will take care of running your Ansible story. And then most of the heavy lifting is within Ansible itself, so very similar to what Jessica was talking about and some of the other groups. So we take a generic CentOS image in this case and come up with a Docker Swarm cluster in a matter of about 15 minutes or so. And that involves bringing up a discovery service, so in our case console. It brings up Docker Swarm, so it'll bring up management nodes and ordinary nodes, and then brings up Flopper, so it brings up our volume manager. And that's kind of what it looks like. So I log into the machine, say Vagrant up, and then just leave it alone for 15 minutes, and it'll come back out, it should bring everything up for me. So it'll define volumes, e.g. for the Docker device mapper in the background, and it will define all machines. At the moment I've split them out, so there's 7 of them, and then it'll start bringing up the networks and configuring Ansible groups. So if you've used Ansible before, then what we're doing is using a dynamic provisioner so that we see what becomes available in OpenStack and react based on that. And then finally it triggers Ansible to actually do the work. So Ansible, in this case, picks a provider-dependent playbook. So for us, that's OpenStack, and then it will take care of the usual sort of boring stuff. So it'll create a certificate authority for us and start handing out certificates to everybody. And because everything that comes after this depends on TLS, so it'll bring up a console cluster. It's the discovery service. It will bring up the Swarm managers and the Swarm nodes. And then it will bring up Flopper agents and Flopper control nodes. And that's actually where we are at the moment. So it brings all this stuff up, and that gives you sort of a working Docker Swarm installation that will let you map volumes around wherever you want. The next step is to connect that to JupyterHub, of course. But as you saw this morning, there's a lot of that's already taken care of, and we're hoping to see a lot of that work. Just pictorially what we have then, so you have JupyterHub talking over the Docker API to Swarm managers in this case, in turn are passing all that through to the nodes, and they're picking out their storage from Cinder, in our case, and OpenStack via Flopper. All right, the idea is that gives us a really nice test bed for pushing some of these limits and seeing where our breakpoints are going to be. But also it gives us, also, we have a lot of open questions that this system doesn't quite answer yet, but things that we're actively looking at. So we realize we're probably going to go for Shibboleth for authentication because we're going to want to cross institutional boundaries and we're going to want to look at class lists and things like that. And we did bring that up and had it working similar to some of the other groups via having Apache in front of it, but I thought quite difficult to maintain and it's probably not something we're going to do longer term. So we're looking at some of the native SAML projects. So maybe write an authenticator, native authenticator process. And once we're shifting to Shibboleth, there's no point in us keeping the concept of POSIX users with each with their own unique UID. So we'll be looking at things like flattening the file system and then just limits to handle essentially directory permissions. And as you point out, that we realize this is not a one-size-fits-all solution. We're not intending to bring all of these targeted users onto a single massive Jupyter hub. It's mostly just for testing and so that we can learn a few automation tricks. And once we have a better idea of those automation tricks, part of the idea is we'd like to be able to go from a very simple interface that we could give to prospective users and to our configuration utilities to giving them a Jupyter hub instance of their own, very straightforwardly and without much interaction on their part. And yeah, we'd like to make it trivial for the researchers to create hubs to suit their needs. So those could be things similar to what we were already doing, or it could be larger installations for research groups, or they could be, they want to run it on different hardware, maybe they're an industry group that wants to run it on AWS or something like that, and they want to make that easy. And just as part of our mandate, we also have a strong focus on training. And the whole idea here is just these tools and techniques part of the everyday vocabulary of our researchers. That's actually all I have. I don't know if I raced through that, but we're aware that a lot of people are doing some very similar things and we're very keen to work alongside them. So if you have any questions or comments, you want to get in touch and we will be sharing all of our bits and bobs via GitHub. So we have the repository organization. Any questions?
Thanks a lot, Ian. While we transition to our next speaker, since we are running a good almost half hour late, I don't know if there's a very, very quick question. Otherwise, it would be a good idea for Mike and Alec from data science to have their slides so that at least we get everyone to present. Mike and Alec, are you folks present actually?
Yes,
Yes,
hey.
they are.
Okay, great. So yeah, if you want to share your screens, and at least we'll make sure that before we hit noon, we do get all the talks, and we're going to end up with a shorter Q&A than we thought. But
Cool. I'm going to share my
you off,
screen
Ian.
now.
Go ahead. Can you share your screens? There we go.
Cool. Great, so we'll get started. So Ian's presentation was a pretty great segue. We've got a lot of Vagrant and Ansible work that we've done, different contexts. So we'll actually get to kind of go quick over some of that stuff. So I'm Mike, this is Alec. We're at Data Science. We're a startup in LA. And we are going to take you through some lessons that we learned in transitioning our data science team onto JupyterHub. So I'm going to intro why we were using Jupyter in the first place, talk about why we decided to move up to JupyterHub and start building what we're building right now. And then Alec is going to take us through most of the talk, which is some interesting challenges that we faced and some solutions to those challenges. So kind of a quick intro, what do we do? We offer consulting solutions and tools to companies that help them get business value out of their data. We have a team of about 20 analysts and data scientists. We're a company of about 50. We do a lot of prediction work, a lot of just taking complex data sets that companies don't know what to do with and turning it into cool info for them so they can run their businesses better. A lot of that analysis happens in Python. We rely heavily on Spark to do a lot of that early data aggregation because we work with very big companies. We work with Tinder, for example, who just generates an absolute ton of data. And then everything that we do in terms of building tools, we're very language agnostic. So we are originally using Jupyter on our data scientist team. So at the time, probably about 5 of us. It grew to about 20 and now more. We were using Jupyter, vanilla Jupyter, actually originally IPython, by actually distributing a repo with Vagrant and Ansible standing up a very small environment for them to do all their work. Remotely, there were databases and Spark on EMR that would help us do that aggregation, like I said. But on our local machines, running in a virtual environment, we'd have our data exploration in Jupyter, visualizations, we'd build models. We would collaborate by shipping our code up to GitHub, particularly our notebooks up to GitHub. And then we have a kind of custom MB convert routine that takes our notebooks and turns them into essentially blog posts for our customers to consume the analysis that we do. The kind of interesting here is that internally we need full reproducibility, which is why notebooks are so amazing. But then for our customers, they really just want to see the output. So we needed another way to get that to them. And that meant writing some custom publishing tools. So in that system, plenty of things didn't go very well. So the top 3 for me are distributing this kind of software on a VM to everybody and expecting them to kind of work on it continuously, not just actually develop on a project, means that the machines drift away, people SSH into them and do crazy things. It's very hard to debug in this environment, and we just have low control. There's a general discomfort in using Git for diffing, particularly for diffing JSON docs. Merge conflicts were just hard for our team of analysts to deal with because it's not really what they're kind of coming here to do. They're coming here to analyze data. So that was always a pain point. And then we were always limited by the amount of RAM on our laptops. So that's pretty straightforward. We'd have big jobs to run and our laptops were not cutting it. But as a startup with limited resources, we said the fastest possible thing to do is just give everybody Jupyter locally. And then deal with the consequences later. And so those consequences are now. So at the bottom of the screen, sort of a summary of what we're doing, what we've done in the past couple months, hosting JupyterHub on AWS for our team, and essentially standing up everything they need there. Hasn't come without challenges. So that's sort of my handoff to Alec. He's going to take you through some 5 interesting things that we've learned in this process.
Cool, thanks, Mike. So as sort of most people, it sounds like are doing, we ended up using Docker to sort of isolate our different environments. One sort of issue that we ran into really quickly, though, was we wanted to be able to sort of have a notion of a notebook that was independent of the actual editing environment. As Mike mentioned, we had this whole publishing workflow. And so we really needed to be able to interact with our notebooks without having to worry about mounting the NFS drive and making sure that we had on-disk access to the file. So what we ended up building for that was a separate REST-based API that a custom content manager could query in order to get the notebook content and do all of the sort of actions that they would do in the UI. And that sort of let us put our notebook logic completely independent of the actual Docker workflow. We sort of had this concern where if we were going to rely on Docker heavily, and then later on down the line, we realized it didn't do what we needed, or we somehow needed to change it. We didn't want to be stuck, with a certain solution that only really supported Docker. And so we made this RESTful content manager, which sort of handled this and some few other problems that I'll get into. It's available on GitHub if you guys want to check it out. So the next challenge that we ran into, it sort of plays into a double-edged sword of Jupyter. Because if things are so easy to just run code, and that's really like the power of it for us, that's really the value add. We need to make sure that on this new system, the users are not going to be stepping on each other's feet. So whether they're doing kind of silly things like, continuously forking processes, or they're trying to be slightly clever doing things in parallel, we needed to make sure that two people wouldn't sort of crash the entire system if they weren't being careful. So this was one of the initial reasons we sort of jumped to Docker, but it became pretty clear that Docker doesn't provide the full support for isolation that we sort of needed. There's still a lot of discussion on how to sort of prevent against these, quote unquote, fork bombs that can take down an entire system. So our quick solution was to write AppArmor and CompuSec security policies, sort of go back to the old SE Linux way and make sure that these processes and their capabilities were really locked down rather than just sort of relying on Docker. So the next sort of challenge that we run into sounds very similar to what other people have been talking about, is that because we're sort of on this large scale shared system, we want to be able to provide users with larger machines than what they would have available on their laptop. And so the way that we handled this was we evaluated a lot of different container orchestration platforms. Specifically, the two big contenders were Mesos and Docker Spawner, and we ended up going with Mesos because it sort of fit into the overall picture of the platform. And part of that was sort of also building out a pretty snazzy UI that lets users sort of customize the containers that they want to be brought up. So the next and sort of biggest challenge that our analysts were running into was that they wanted to be able to really quickly collaborate on these notebooks. And rather than sort of relying on good practice or maybe just communication, we ended up building out this big locking system where when a user opens a notebook, it records in the RESTful content API that I had mentioned earlier, saying someone's reading this notebook. And when another user goes to open up that notebook, they get a little alert saying, oh, this notebook is locked and it's opened in a read-only mode, which sort of lets users collaborate and sort of watch over other users quickly without having to worry about where how the mutual changes are being handled. One sort of thing to add to this is because of the, let's go with quirks of browsers, it was really hard to sort of track user-specific sessions. It was difficult to get a reliable on-close event of the browser that we could use to release the lock. So we first started off with a pretty traditional AJAX system where a request would get made when the notebook was brought up, but that we quickly realized that we couldn't rely on the browser to sort of tell us. And so we set up this WebSocket system, which gave us a much more reliable way of listening for the disconnect of the WebSocket. So even if the user just closed their laptop without closing the browser, we still got an alert. And another sort of part to this problem that Mike brought up earlier was we were previously really relying on Git. So a lot of our analysts could sort of navigate, but when it came time to actually handle these large merge conflicts, it was a not so feasible task. And on top of that, they didn't really need all of the complicated forking and, pull request workflow that sort of GitHub really enforces. It just became a lot of kludge surrounding our workflow. So we took advantage of the RESTful Content Manager again to sort of handle a linear snapshot system of checkpoints that were served over this REST API. So these were immutable records of the notebook, and as a user works, they can make new records and can sort of build in layers. When it came time to revert back, we end up making a new copy of that thing rather than changing the content. So we can get a pretty good timeline of how that notebook matured. And the final thing, that challenge that we ran into was this: we had power users who needed notebook-specific packages installed to make their analysis work. And so what we ended up building was we added this little script to the IPython startup files that start the notebook in a Python virtual environment, which provides really good isolation between these separate notebooks. So this allowed us to sort of have one cell where the user can just say, bang pip install scikit-learn and would get that installed for just their notebook, providing not only an easy way to install it, but an easy way to sort of list what the specific dependencies are for that notebook. You could open up any notebook, the top cell traditionally would have the requirements, you would run it, and then you were guaranteed to be able to run the rest of the analysis. So that pretty much sums up the challenges that we faced and how we solved them.
If you have any questions for us, we'll be on Gitter. Also, if you want to check us out, we're capital D, capital S, data science. Yeah, thank you, Fernando, and Jamie as well.
Thanks, folks. That was great. Again, in the interest of time, let's move forward with our next speaker. Jonathan, are you ready to take over the floor?
Yeah, I think so. Just a minute. Let me figure this out right here.
Go ahead and share your screen.
Yeah.
I'll just comment that it's very nice to have a CU Boulder presentation, given that IPython was born 15 years ago out of procrastinating at CU Boulder. Here.
Excellent.
Go ahead.
Yeah, forgive my lack of slides. This is very last minute, but we gave a tutorial at Exceed about deployment, and we were turned on to this group. So thank you for inviting us and for a chance to participate. So we're a pretty traditional HPC center. We have a couple just kind of normal batch processing clusters. And our main goal is to provide JupyterHub as a front-end interface to those to either to replace kind of interactive prototyping or interactive computing that people might use an interactive batch job for, or an alternative to our general purpose is the people. And there's the terminal interface, but there's a lot of other benefit to having a notebook interface for that. So what we have today, we have a couple of JupyterHub servers deployed in a vSphere cluster in a couple of different ways as we kind of prototype this. We've got a few users from one of our semi-internal groups using the system, but it's still very early days for us. We're iterating kind of rapidly on how we actually want to deploy and use the system. We use the PAM spawner to authenticate to basically our entire upstream user infrastructure. So we have Active Directory behind an AD infrastructure, and we also have a legacy Vasco-based two-factor thing that we do over Radius, and it's kind of all handled by our existing PAM stack. We publish a bunch of software, including a bunch of Python modules and a Python kind of HPC-ish optimized Python environment using LNOD, and we provide some of that through this interface. And then we have a bunch of global file directories. Mostly it's NFS, and our home directories and home-like directories are in there. But then we also have a Lustre Scratch file system, and the new cluster that we're deploying right now will have a GPFS Scratch file system. And all of those are available on the login nodes, and we kind of want them to be available using the JupyterHub system in at least a similar way. So today we have 3 kernels installed, well, 4 if you count the default Python 3 IPy kernel. We have the bash kernel installed just because it's crazy and awesome. We have the IR kernel installed, and then we do actually have the Python 2 kernel installed, and there's some crazy shell script wrapping around that to get that to work. We have IPy Parallel set up, so we distribute a set of kind of predefined IPython profiles to each user as they log in. That gives them a couple different ways to submit IP engine clusters into each of our compute environments. And then we also make sure that those IP engine clusters are configured for MPI. So you can use MPI for Pi to run MPI code against that also. Our first deployment, and the one that we currently consider the closest to production, uses Batch Spawner to deploy the actual notebook server into a serial cluster that we have. It's a Dell Blade Center system. The next iteration, that's kind of a prototype or more of a prototype than that, doesn't use that. It just uses, it only uses the remote systems for the IP engine clusters. I hadn't seen the profile spawner before. That's one of the reasons why we moved away from it for the next iteration, is we didn't have any way to control how that notebook server got spawned or what cluster it got spawned into. So knowing that that exists is pretty interesting for us, and we'll have to look at that. Although I do think that what we'll probably do for the next iteration of our prototyping is go or look at this remote kernels project. And I haven't looked too closely at it, but it lets you spawn not the notebook servers or the notebooks, but just the kernels on other compute systems. And I think that's probably what we're going to look at for the next thing. But if anyone's used that, I'd be interested to hear what your experience has been. Other things that we kind of run into, and I understand that these aren't all JupyterHub issues. A lot of them are either IPython parallel issues or notebook issues. But we'd like to see first-class support for virtual envs in the kernel configuration file. So I don't know if you've used like micro WSGI. When you do that, there's an actual virtual env parameter that you can pass to the config file that makes all of the activation happen for a virtual env automatically. And that's really useful. Our Python 2 stuff in particular is in a different virtual env than the Python 3 stuff that JupyterHub is in. And so the ability to switch over to that just for the kernel would be really useful if it happened automatically. Like I said, we deploy existing profiles and some other configuration to a user when they log in the first time. And we did that by wrapping this single user command with a wrapper script and doing the user initialization in there. But it would be good if that default spawner supported some kind of thing like that by default. With the batch spawner, we did this with the with extra launch script, I think is what it's called. So that same kind of functionality would be useful in this case. Let's see what else. Oh yeah, so a big sticking point for us is how limited the IPy parallel kind of web interface tab is. So the first thing is that all it really lets you do is specify how many engines you want. And so what we do is kind of give a matrix of kinds of profiles. Mostly that's like, we do 2 for whether you want 1 engine per node or 1 engine per core, but then you would probably want users to be able to say how much memory they want, that kind of thing. And being able to expose additional parameters to your IPy cluster spawner would be useful. And then even more importantly, that status field is pretty useless when you're using a batch system. It says started when really all it's done is submitted the job. And so it would be good if the batch, not batch spawner, I guess it's just IPy parallel has this, the Slurm support built in now. It should be able to feed queue status back into that field and tell you that your job is queued or waiting, that kind of thing. Or if it has failed in a way that is past the submission. Yeah, so another thing is that Jupyter Notebook is really opinionated about only letting you navigate underneath your kind of initial working directory, which is usually your home directory. But this is a limitation for us because we do have other shared file systems that our users use for kind of project shared space. And right now we're directing them to just create symlinks to those from their home directory, but those do exist higher in the tree. So it would be...
I think we ended up implementing that, so feel free to reach out after this and we can talk about how we did that.
Who is that speaking? I'm sorry.
This is Shreyas from NERSC, and there's a discussion on the Gitter chat about just that, actually.
All right, excellent. Yeah, I figured it wouldn't be a big deal, but I think it's positioned as a security feature in the documentation, but that's really a misnomer because once you're in a notebook or in a terminal, you can do whatever you want, right? So, yeah, I'm glad that other people are working on that already.
It's not a security feature of ours. It's a security feature of the web server we use.
Okay.
And that if you point it to a directory to serve, it doesn't serve files above that.
Sure.
But you can, as Shreyas actually showed in his demo, you can serve from root, but then default to somewhere else.
So that is kind of expected that was probably a way you could implement it, but I hadn't looked closely into it.
The starting point and the serving root are actually separate things that default to the same thing.
Excellent. Sorry I missed that during the previous demo.
That's okay.
It would also be cool. So right now we just have we have a couple different JupyterHub instances, but they're explicitly isolated from each other there so we can test different ways to deploy it. Right now, our user population is small enough that it doesn't matter. But as load goes up, it may be the case that we'll need more than one in kind of a clustered setup. And it sounds like the Docker spawner can do that. I don't really have any Docker experience. So I'm not sure. Right now, the plan was to just put some kind of consistent load balancer in front of the JupyterHub servers so that a user would always go to the same one. But I'd be interested in seeing what other people have done for that. But if we do end up using remote kernels for everything, it might be that the load doesn't matter on the front-end web server because all of the compute would be somewhere else. And then I don't know if this actually exists already, but it would be cool if we could spawn terminals in remote systems also. So how we're using the remote kernel or the IPython parallel stuff to dispatch things using Slurm into a backend server. It would be cool if someone could say, I want to open a terminal in that cluster over there. And that would then completely replace interactive jobs for us, and that'd be great. Because that tends to be a point of confusion and sticking point for a lot of our users who just come in over SSH. It would be great. I gave a much more thorough talk on our implementation and how we did the deployment at Exceed just earlier this week, and the slides for that are here. And I might just end up submitting a PR for the repo here to point at those slides rather than posting my dumb little text buffer here. But I know we're behind on time, so I can take questions here or in Gitter or later.
Yeah, why don't we take the questions on Gitter so that we have a chance for Corey to give the last presentation, and then we'll have like 3 minutes basically to wrap up. I think we basically ate up our time. So go ahead, Corey, please.
You actually have my slides.
Okay, so Jonathan, if and let's see, hold on a second. So
it's like BAA, JupyterHub, OAuth, or something like that.
This one. Tell me to do next.
Cool. So I was going to talk about building some Authenticator and how it's done that.
Somebody who's typing a lot needs to mute themselves.
Oh, sorry, that's me.
Thank you.
All right. So yeah, we're building kind of a Internet of Things cloud-based application that is collecting data and then exposing that data to JupyterHub. We have a separate admin that's like a dashboard, and we wanted to be able to use those users that already existed to log into JupyterHub and then configure an API, pull in their data, and kind of limit their access to what they can get into as far as notebooks go. So we needed an authentication wrapper, and I started looking around. I'm totally new to Jupyter notebooks, like completely, and I'm a web developer. So it was kind of a huge learning curve, like JupyterHub, Jupyter notebooks. I haven't written Python in 3 years, like it's just uphill. Basically this is kind of our motivation. And the other thing we wanted was multiple environments for development and staging and production. So next slide. All right, so Authenticator already exists, and it gives you a bunch of out-of-the-box options, which are great. Bitbucket, GitHub, CI login, there's a ton of them, and it's a really nice package. So if you haven't looked at it, check it out. Next slide. Basically, it abstracts away a lot of what you need to do here. So if you're not familiar with OAuth, you have an authorization application, and you have a request that you make to it with a specific set of keys. And then if a user is logged in and gives you access, then the application does an exchange of these keys to get access to the API and other tools to get user information, etc. And actually, the next slide, please. Building a custom authenticator wasn't super hard. There's just some real kind of weird things about working with Tornado and trying to understand the way that it's tied together with JupyterHub, and also just realizing that there's all these like asynchronous calls that are kind of happening was a bit tricky. So next slide. All right, so I think the best way to start if you're going to do this is to grab an existing authenticator. If you're going to do that, be careful, because some of them are OAuth 1 and some of them are OAuth 2, and some of them are doing just something completely different depending on the service. I grabbed the GitHub authenticator because it was pretty clean. The GitLab authenticator is also pretty clean, so those are good starting points. Next slide. And OAuth 2 mixin is really kind of what you need to pay attention to. this seems to take care of a lot of what you need to do, and it's pretty simple. It's really a configuration setup. So you just grab the authorization URL, the access token URL, and configure those things. And then the OAuth 2 library inside of Tornado does a lot of the token exchange and everything for you already, which is nice. Next slide. So Authenticator is where you actually like do something, and the main thing that you need to worry about, if you look at the Authenticator library itself, is overriding these three things: a login service, a login handler, and an authentication method. So login service and login handler are just, the login service is literally, from what I can tell, just used for the button name, and then the login handler, you're probably just going to want to subclass OAuth login handler, because it does probably what you want it to do. As far as the authentication method, that is where you probably want to do some sort of token exchange, key exchange to get access to your API and get information about your user. Ultimately, what you want to do is the thing that the JupyterHub auth requires, which is returning some sort of a user's unique identifier. Next. Yeah, I just talked about that. Now, the only thing here is that a lot of the back and forth is kind of happening asynchronously, and you won't see it happening in the browser, and it's kind of really gets confusing. So you want to like log everything out, and it's not obvious, but self.log debug is how you do that. It's not documented anywhere. None of the other libraries do it. But you need to use that. Next slide. The other thing you need to do is a login handler. So as you start digging through these things, there's like a main login handler in all of them, and then a local login handler in all of them. And from what I could tell, the only difference is that people use a local login handler to actually create a user, a PAM user on the Unix system. With the local login handler, and beyond that, nobody seems to be using it for anything different. It's just a subclass of the other one and gets a prefix name of local. This is a convention. Okay, next. Local authenticator, I just talked about that. Next. All right, configs. All right, so this is where a lot of the setup is done. We used environment variables to configure all this stuff so that we could, switch between different environments. Now, it kind of magically just happens that if you configure these .auth callback URL, .client ID, .client secret to your authenticator, if you inherited from the right classes, they just get added in and start working, which feels very magical, and you just kind of have to know that that's how it works. There's not really good documentation about how to build one of these things. So unless you're going to dig through all the source code and figure it out, in which case you're going to go through the Tornado source code, and you're going to go through the JupyterHub source code, and you're going to go through the Authenticator source code as well. You just kind of got to figure out that you need to set these things. And then create system user true, from what I can tell, creates the Unix user on the system for you if the user doesn't currently exist. Now, one weird thing about this is it creates a system user, but it also creates a database user. And the database actually seems to control all of the authentication credentials in the notebook and what they're attached to. And the first time through, since it's both creating the user and logging them in, it creates both. Okay, next slide. Cool, so lessons learned. Developing this locally can be a real pain because there's a lot of SSL certificate security stuff, and you start running into all kinds of weird problems where Tornado won't accept a locally signed certificate, and your local server doesn't properly assign it or use it, and then the OAuth library won't take it, and you spend like a week just trying to figure out why SSL certificates aren't working. And then you get mad and you buy a certificate, or you spin it up on a Heroku instance, and you're just like, whatever. There's a lot of message passing going on, so you need to have your logs open for both applications and see the handshake happening, because it can die on either side. And there's a lot of like trickiness to making sure that those like really long digits of numbers are getting passed around correctly. The Authenticator library will do a lot of the work for you. So mainly just focus on your endpoints, and a lot of the other stuff is just noise. The one thing I can say is that getting your user into the system can be difficult, especially considering the name constraints that Linux puts on usernames. So be careful about any username that you're pulling in from an authenticator. I've been playing with ours, and I was using email addresses, and I ran into an email address that wouldn't authenticate on Unix, right? So then, like yesterday, I was like starting to rewrite it, and now everything broke. So, and there's really weird stuff that happens too, like if you delete a user out of the database, but they're still in PAM, like JupyterHub won't start. There's some like weird nuances where it tries to create users that it can't create and it won't start. So be careful about that. And then again, self.debug, log.debug is your friend. So next steps for us, we really need to store API credentials somewhere. I've seen a thread where UV Panda is doing something like this on GitHub, but I haven't seen anything that makes any sense to me about how he's actually doing it.
Yuvi couldn't join us. He's traveling today. So he was going to join, but he's on today on travel.
Yeah, he's got like something where him and Min are going back and forth about the right way to do this. And then he's like, I figured it out. Like, and then we're investigating shared folders, which sounds like a lot of people are. User groups and shared folders. Thank you.
Okay, well, thanks, Corey. That was great. Again, we've basically run the clock on time. So I think instead of trying to open it up for discussion in 3 minutes, which isn't going to work, I wanted to just say a couple of things. First of all, there's one thing that I want to show very, very, very quickly, which is this, because some of you may not have seen the talk that Brian and Jason presented at SciPy last week. This is Jupyter Lab, which is effectively the next generation of the notebook user interface, or what we today call the notebook, which actually is a misnomer because it has a file manager, it has a terminal, it has a text editor, it has a process viewer, etc. Now we've kind of restructured that into what's called Jupyter Lab. It's on a repo on the organization. And what it gives you is basically a unified UI for the file manager, for notebooks, for consoles. So this is an example of a graphical console here instead of it being a notebook, but you can also have a notebook next to it. You can have terminals. You can reorganize these things. And drag them and restructure them. So for those of you who have repeatedly brought up use cases where, especially in the interactive HPC context, where you do want to have terminals and other things to replace many of the existing HPC tools, this is where the system is going, and it's worth watching it. We put it out, we announced it in alpha at SciPy last week. So it's worth at least keeping an eye on it and beginning to play with it and see if it meets your use cases or not.
And the question there is Jupyter Lab actually meant to replace the notebook, or is it a supplement or alternative?
No, I mean, the notebook application, what we call the notebook application today, as I said, is kind of a misnomer because the notebook application has tabs for text editors and terminals and whatnot. So that has been subsumed into what we call Jupyter Lab. You could argue that Jupyter Lab might have been a better name even to what we have already today, but this UI unifies all those into something which is where they can be viewed together, and each of these things is actually a plugin that can talk to the others. There's underlying JavaScript APIs for these things to communicate, to add your own new plugin. So a plugin that could monitor Slurm jobs or things like that could be added to this page.
So it looks like Jonathan Anderson is looking for a very specific answer. Is it a replacement of the notebook or a supplement?
Yes, I mean, it is a replacement of what we call Jupyter Notebook. Today you type Jupyter Notebook, eventually you'll type Jupyter Lab. One important point to make is that the notebook documents that are here, so the notebook, these notebook documents right here are actually the same files on disk. So in the sense of the notebook has it, the problem is that the word notebook today has two meanings, the documents and the applications. So this will replace the application, the Jupyter Notebook application, into a framework that captures all of the existing notebook application use cases, the notebook documents remain the same. And they're actually unmodified. In fact, you can simultaneously open a notebook in lab and the old notebook, and it's the same exact document on disk. I hope that answers the question. Anyway, I didn't want to take too much time on this, but you can watch Brian and Jason's talk from SciPy from last week if you want more details, but it came up enough times in my notes that I wanted to at least flag it for people. Otherwise, I think we need to wrap it up. I want to give a big thank you to all the speakers, to the audience for coming and joining us, and very especially to Jamie for doing a lot of the heavy lifting and logistics with us. Carol and Matthias also helped a lot. Carol put a ton of work on the repo and in managing the PRQ documentation and improving the mess that I started with the repo. This was put together in my usual hackish, hasty style, and I appreciate that everyone made it actually work well. And also for those who were taking notes, I think we had some of the Cal Poly folks were working with us on the notes, and I really appreciate that. And anyway, we will, for those of you who have updates to your notes or slides, please put them up. We'll dump eventually the notes from today into the repo as well. And I think the one thing that is, I think we will need to think about as a team is basically making a little bit of a sort of a concept mind map of everything that emerged today to see, okay, what are the points where what are the really high order bits in terms of feature requests or problems? But I encourage you to submit issues like that as issues to the main JupyterHub repo so that we can track them as official kind of development. So if there's anything that's very high priority, please submit it as an issue request on the repo. Anything that I've missed other than, again, saying thank you to speakers, audience, and everybody who pulled in to help us with logistics, Anna, Carol, Jamie, the note takers, and Matthias. What's that? Reese. Reese was the one who's taking the notes. Awesome. Thank you so much. All right. The other thing is then I'll stop here and I will, that's us here. I don't know if you can see us on video or not.
Is this a different Gitter or is this a good place for these folks to hang out afterwards if they want to communicate this Gitter channel?
Yeah, absolutely. I mean, eventually it'll probably die off, but for now, while there's discussion, yeah, we're not going to close the room. And so we will, once I can download the recording, I'll post it on YouTube and we'll add a link to the YouTube video onto the repo. So I'm stopping the recording now. Thank you, everybody. Thanks, Internet. We had about 50 people total, roughly, which is great. And we'll post the recording after.